So multiplying rational expressions. All right, let's look at the first example. Okay, so we're going to have to review something first from a previous course. What is x to the 8th times x cubed? What is that equal to? X to the 11th. So when you multiply like bases, you do what to the exponents? When you multiply like bases, you do what to those exponents? You add them. So remember, that's called the product rule. The other thing you learned in the previous course was this. X to the 8th divided by x to the 3rd. What is that equal to?
X to the 5th.
X to the 5th. When you divide like bases, you do what to those exponents? Subtract them. So you're really saying x to the 8th subtract 3. And what's 8 subtract 3? 5. So that's called the quotient rule. Right, so this was the product rule for exponents, and this is the quotient rule for exponents. All right, so that's going to be needed with what we're about to do. Okay, so now we're going to simplify. Multiply, rather. Let's call it multiply. Number 1. You have 6x divided by 5 times 2x to the 4th divided by 3x squared. So 6x divided by 5 times 2x to the 4th divided by 3x squared. So notice you have these two rational expressions and you're multiplying them. You don't see any addition or subtraction symbols. They're all multiplication. So all these are factors. Now there are a couple ways you can do this. So you can remember from a previous course a long time ago, a long time ago, when you had 3/4 times 5/7. What did y'all do to multiply these two fractions? You multiplied the numerators and multiplied the denominators, right? And then you reduced if you could. Or you could have reduced first. It does not matter. I can't reduce anything, so I'm just going to go ahead and multiply the numerators. 3 times 5 is 15. 4 times 7 is 28. You can do the same thing here. You can multiply first. So what's 6x times 2x to the 4th? What do you think that equals? 12x to the 5th. 6 times 2 is 12. X times x to the 4th is x to the 5th. Divided by, and what's 5 times 3x squared?
15x squared.
15x squared. So that's where I'm at. Okay? So I multiplied first. Now you got to reduce, because I do have common factors. So for example, if I look at the 12 and the 15 for the moment, can I reduce 12 15ths? Do 12 and 15 have a common factor? 3. 3 goes into 15 5 times. 3 goes into 12 4 times. Right? Now I'm going to circle these two factors, the one that has base x. We just had a discussion a while ago. What is x to the 5th divided by x squared?
X to the 3rd.
X to the 3rd. When you divide like base, you do what to the exponents? You subtract. So you're really saying x to the 5 minus 2, which is x cubed. Okay? So when I come over here, then I'm going to say 12 15ths, which I've reduced to what fraction? 4/5. Now remember, you want to write your answer as one fraction, though. One fraction. So my numerator is going to be 4x to the 3rd, and my denominator is going to be just what number? 5. So there's your answer. 4x to the 3rd divided by 5. Now that's one way to do this. The other way you learned was this. So let's kind of review something from our previous course. Suppose I had 3/4 times, and let's make this 10 over 15. So rather than multiplying first, I could do what here first? Reduce. So I could say 3 into 3 is 1, 3 into 15 is 5, right? And then I could say I can still go further with this. I can reduce this 10 in the 5 if I wanted to, or I can reduce the 10 in the what? The 4. All right, so some of you may do the 10 in the 4. So you say, well, 10 and 4, what fact do they have in common? 2. If you did the 10 and a 5, what fact do they have in common? 5. Good. So 2 and a 4 is 2, and 2 and a 10 is 5. And then you can reduce even further, right? Because what do you notice here? That can be reduced. 5 and a 5 is 1. 5 and a 5 is 1. But when you do it this way, it becomes a little bit messy. But in some situations, it might be better to do it this way. It might be better to multiply out first and then reduce. So you get 1 times 1, which is 1, and then 2 times 1, which is 2. So the point being that when I look at number 2, I have 12x cubed divided by 25 times 40 divided by 9x squared. Multiplying first, you're going to end up with 12 times 40, so that's going to be a 4-digit number, which may be a little bit more difficult for some of you to reduce with the denominator. So what you may want to do first is reduce first. Reduce the coefficients first. So if you look at the 12, will 12 reduce with a factor down here?
Yes.
Which one? The 9. What do 12 and this 9 have in common? 3. So 3 into 12 is 4. 3 into 9 is 3. Now let's do the 40. 40 can reduce with what number? Not the 5, that's a 25. What you mean is that the common factor is 5. So 5 into 25 is 5. 5 into 40 is 8. All right. Now at that point, once I see it's getting a little bit messy at this point. So what I would do at this point is all right, I reduce the coefficients. Now let's go ahead and multiply these out. So I'm going to get 4 times x cubed times 8, which is 32 x cubed, right? And then my denominator will be 5 times 3 times x squared, which is what? 15x squared. And at this point is where I would reduce the variables. What is x cubed divided by x squared? That's just x. Because remember what you're saying is x cubed divided by x squared. When you divide like bases, you do what to those exponents? Subtract them. So it's x to the 3 minus 2, which is just x. But how are you going to write the answer? You want one fraction as the answer. So you're going to say what? 32x divided by 15. So that'll be the answer. All right, number 3. You have negative 7a cubed divided by 2a times 3a squared divided by 14a to the 4th. So negative 7a cubed divided by 2a times 3a squared divided by 14a to the 4th. The numbers aren't that big, so you could multiply first if you want to and then reduce. Or you can reduce the coefficients first and then multiply. It's up to you. Which one do you want to do first? I really don't have time to do both. Which one do you want to do first? You want to multiply? Okay. What's a negative 7 times 3? All right, so I get negative 21 in the numerator. What's a cubed times a squared? a to the fifth. So that's what I have. All right, let's talk about the denominator. What's 2 times 14? And what's a times a to the fourth? A to the fifth. All right, so that's where I'm at. So I multiply first this time. Now let's go ahead and reduce. What do negative 21 and 28 have in common? What's the common factor? 7? Okay. So 7 will go into 28 4 times. 7 will go to negative 21 negative 3 times though, right? Let's look at the variables now. What is a to the fifth divided by a to the fifth? What is, you're not telling me what it is though. What's a to the fifth divided by a to the fifth? It's 1. Anything divided by itself is 1, right? 6 divided by 6 is 1. 8 divided by 8 is 1. X divided by x is 1. Now, when we did the others, though, we actually used the quotient rule. So when I came here and I said x to the fifth divided by x squared, we said we subtract the exponent. So 5 minus 2 is 3, so we got x cubed. Here, 3 minus 2 is 1, so we just got x to the first, or just x. But here, remember this. You can use the same idea when you divide like bases, you do what those exponents. You subtract. So let's see if you remember this idea. If I have a to the fifth divided by a to the fifth, that is really a to the 5 subtract 5. But what's 5 subtract 5? 0. Remember, last semester, this is called the zero exponent rule. So really, that meant that if you take a number that's not 0, so anything not 0 raised to the 0 power, that's always equal to what number? 1. So for example, if you take your calculator and you ask yourself in your calculator, what is 8 to the 0 power on your calculator? 8 to the 0, you say 8, and then I'm going to raise it right here to the 0 power. See how it looks? 8 to the 0 power. You press equal. What do we end up with? 1. So any non-zero number, as long as the base is not 0, if you raise it to the 0 power, you're going to get 1. So for example, negative 3 to the 0 power. Now notice I put negative 3 in parentheses now. That's your base. Your base is negative 3 here. So parentheses, negative 3, close parentheses, and I'm raising it to the 0 power. And notice when I do that, I still get what? 1. Now don't confuse this right here, that negative 3 in parentheses to the 0 power, with this. We talked about this in the past. You dealt with it last semester as well. What is the only thing being raised to the 0 power in this case? The 3. Good. So if I look at what's boxed off, what is 3 to the 0? 1. So this becomes the what? Negative 1. And if you put that in your calculator, notice no parentheses, right? So in your calculator, look, you get negative 3 raised to the 0. So notice no parentheses. When I press equal, I get a negative 1. All right? So this right here, a to the fifth divided by a to the fifth, anything divided by itself is equal to what number?
1.
1. But how do I prefer this answer being written? What's the answer? What's the numerator? Negative 3. What's the denominator? 4. Negative 3/4. All right, now let's look at number 4. All right, number 4, you have 3 times x plus 2 divided by 4 times 12 divided by x squared minus 4. Now notice in the first 3 problems that we didn't have anything in the numerator or the denominator that had a addition or subtraction symbol. Now we do. So just like before, the stuff we did at the beginning of class and what we did last week, you have to factor first. If you look at this numerator right here, it's already factored for you. You can see the factors. What are the factors?
3.
3, and what's the other factor? X plus 2. So it's already been factored for you. The 4 is a monomial. Leave that alone. The 12 is a monomial. One term. Think of one term. Leave that alone. But look at this. This is not factored. You could have had this in your last test. How do you factor x squared minus 4? What is it? Difference of two squares. So I'm going to go right underneath here. I'm going to factor it. How do you factor x squared minus 4? X plus 2, x minus 2. So step 1 is to factor, just like you did previously. Step 2 is to reduce, just like you did previously. The way you want to do this, though, is you want to go through your numerators and look at each factor. What's the first factor I see in the numerator? 3. Will that 3 reduce with a factor in the denominator? Now, before we go on, how many factors do you see in the denominators altogether? How many factors do you see in the denominators altogether? 3. They are 4. What's the other one? X plus 2. What's the other one? X minus 2. So if you're going to succeed with this, you need to know what your factors are as well. So I have a 3. Will 3 go to any one of these factors? No. Now what's the next factor you see? X plus 2. Will x plus 2 reduce with any of these factors? Yes, because there's an x plus 2 down here. So remember, we cross them out, though. We don't leave it like that. It's 1 because remember, anything divided by itself is what? 1. So we put 1s in their places. The next factor I see is a 12. Will that 12 reduce with any factor that's in the denominator? Yes, which one? The 4. So 4 into 4 is 1. 4 into 12 is 3. Now you write your answer as one fraction. So you can multiply all the numerators together. So when I look at all the numerators, all the factors that are left in the numerators, I have 3 times 1 times 3. What is that? 9. The denominators, I have 1 times x minus 2. What is that? So there's your answer. 9 divided by x minus 2. Number 5, we have x minus 7 divided by 1 times 6 divided by x squared minus 7x. So x minus 7 divided by 1 times 6 divided by x squared minus 7x. Number 5, that first numerator, x minus 7, can I factor that?
No.
No. The GCF is 1, right? Nothing you can do. And the denominator and the numerator here, those are monomials, so leave those alone. You can't do anything else to that in terms of factoring. But look at the denominator. How do I factor this denominator? The GCF. What's the GCF? X. So I can factor this as x times what? X minus 7. So once you factor, what's the next step? Reduce. What can I reduce? X minus 7s. So I'm going to divide out these x minus 7s. Now remember, I'm crossing these out, but you got to put something in its place. What goes there? What factor goes there? 1 in both of them. And that's all I can do, because the next factor is a 6 that you see. Will that 6 reduce with any factor left over? No. So what's the answer? 6 divided by x. Y'all agree? 6 divided by x. All right, number 6. You have a plus b squared, a plus b squared, divided by a minus b, times a divided by a squared plus ab. So a plus b squared divided by a minus b times a divided by a squared plus ab. All right, first step is to factor. So just out of curiosity, what can you factor in this case? Yeah, so that's the only thing you can factor, right? Because you may say, well, that numerator looks different. Well, you had something like this before. A plus b squared means what? A plus b times a plus b. So it's already factored for you. So what I would do is I would write this out twice. I would say, well, that's going to be a plus b times a plus b. So it's already been factored for you. The denominator here, there's nothing you can do. The GCF is 1, so leave it as a minus b. The numerator is a monomial. Leave that alone. All right, now let's talk about the denominator. What's the GCF? A. So I get a times what? A plus b. All right. So I factored. Now the next step is to reduce. What's the first factor you see in the numerator? A plus b. Will that reduce with a factor down there? Yes. Remember, you divide them out. You put factors of 1 in their place. The next factor you see is also an a plus b. Will that reduce with any factor that's left? No. Because the only thing left is a minus b and what else? A. Because that's a 1. The next factor is an a. Will that reduce with a factor in the denominator? Yes, because there's an a here. So a, what is left in their places? 1. And that's all you can do in terms of reducing. Now the next step is to multiply your numerator and denominators out. So what's going to be the numerator of your answer? A plus b. What about your denominator? A minus b, because 1 times a plus b times 1 is just a plus b. A minus b times 1 is a minus b. All right? Number 7. Okay, number 7, you have 9x plus 3 divided by 3x minus 1 times 5 minus 15x divided by 3x plus 2. All right. So you want to multiply these two rational expressions. What's the first step? What's the first step? What's the first step? Factor. How do you factor that numerator, that first numerator? GCF. What's the GCF? 3. So I get 3 times 3x plus 1. Can I factor the denominator? No. So I say 3x minus 1 times. How do I factor that numerator, the second fraction? GCF of 5. So that's 5 times what? 1 minus 3x. Can I factor that second denominator? No. All right, so I factored everything I could. All right, now we reduce. What's the first factor you see? 3. Now before we go on, let's talk about the factors that are located in the denominator. How many factors are in the denominators? 2. 3x is not a factor because you're subtracting 1 from it. All right. So if you're thinking negative 1's a factor, this would have had to been 3x times a negative 1, and that's not what this is. So there are 2. What are they? 3x minus 1, and what's the other? 3x plus 2. Okay, let's talk about the numerators. What's the first factor seen in the numerator? 3. Will that reduce with a factor in the denominator? No. In order for 3 to reduce with a factor in the denominator, one of your factors has to be a number, like 3, 6, 9, 12. You may say, well, there's a 3 there, but remember, 3 is not a factor. What is the factor? 3x minus 1. That's your factor. Okay? All right. What's the next factor you see? Does 3x plus 1 occur as a factor in the denominator? No. What's the next factor you see? Does 5 occur as a factor in the denominator? No. What's the next factor you see? Can I reduce that with anything in the denominator? Yes, because you see it's opposite. So the opposite of 1 minus 3x is what? 3x minus 1. So remember, when you cross them out, we tend to make the denominator 1 positive 1 and the numerator a negative. That's the way we prefer to write it. All right, let's write the answer now. Now remember, if you look at the numerator, how many factors do you see altogether in the numerator now? There's this one, that's 3. The other one's 3x plus 1. What's the next one? 5. And what's the next one? Negative 1. Remember, multiplication is commutative. The order in which you multiply does not matter. So the way you want to do this is this. This 3, this integer, I can multiply with this integer factor 5. And what's 3 times 5? And what's this 15 times negative 1? Negative 15. So you want to write this as negative 15 times what? 3x plus 1, just like that. And what's the denominator? 3x plus 2. So that's how you want to write this. Now, if you went ahead and you distributed the negative 15, that's fine. So I wouldn't take off any points. If you distribute, that would be negative 45x minus 15. Is that correct? Over 3x plus 2. That's okay. You can write this if you want to. That's fine. But I tend to most times just leave it in factored form. Okay? All right, number 8. Okay, in number 8, you have this. You have x squared minus x minus 6 divided by 6x plus 24 times 18 divided by 3 minus x. So x squared minus x minus 6 divided by 6x plus 24 times 18 divided by 3 minus x. All right, what's the first step to multiplying rational expressions? Factoring. You got to factor first. Can I factor that first numerator? Yeah. So let's see what we get. So it'll be x, 3 and 2 will work. Yeah, x minus 3x plus 2. Again, just real quick, check to make sure whichever is correct. The outer is a positive 2x. The inner is a negative 3x. When I add them up, I get a negative x. And then negative 3 times a positive 2 is a negative x. How do I factor that the first denominator? GCF of 6. So it's 6 times what? X plus 4 times 18. That 18 is a monomial. Leave that alone. And then 3 minus x, I can't factor that. The GCF is 1. So the only thing I was able to factor is the numerator and the denominator, that first fraction. So once you factor, what's the next step? Reduce. What's the first factor you see? Will that reduce with anything in the denominator? Yes, because this one and 3 minus x are opposites. So I'm going to cross these out. This factor is going to be 1, and this factor will be a negative 1. The next factor you see is x plus 2. Is there an x plus 2 is a factor in the denominator? The next factor is an 18. Will that reduce with a factor in the denominator? There's a 6. There's a 6. So 6 will go to both of those, right? So 6 and a 6 is 1. 6 and 18 is 3. So you need to look at that. You need to be careful. And it's all you can do in terms of reducing. So now let's write the answer. How do you think the answer should be written based on what we did previously? Very good. -1 times 3 is a -3 times what? X plus 2. And the denominators is going to be what? X plus 4. Now, if you want to distribute the -3, you can. What would you write it as, though? -3x minus 6 divided by x plus 4. But again, this is the one we prefer you write. This right here. Okay, one more with multiplication. Let's look at this one. All right, let's suppose we had 5x plus 30, number 9, 5x plus 30. Divided by 4x squared minus 12x times 2x squared minus 5x minus 3 divided by 4x squared minus 1. So 5x plus 30 divided by 4x squared minus 12x. And your second fraction, the numerator, is 2x squared minus 5x minus 3 divided by 4x squared minus 1. All right, let's look at that first numerator. Can I factor that first numerator? How do you factor that? GCF of 5. So it gives you 5 times x plus 6. Can I factor the denominator? How? GCF of what? 4x. So it'll be 4x times x minus 3. Is that correct? Okay. All right, now the next fraction, the numerator. The GCF is 1, but it's quadratic trinomial. So I'm going to do the two binomials. 2x and x. The only possibility for 3 is 3 and 1. And I think the 3 is going to go in the second parentheses. And the 1's going to go here. And the last sign's negative. That means these signs are different. Which one do you think is going to be the plus and the minus? The 2x what? Plus 1 or minus 1? Plus. And it'll be x what? Minus. All right, and make sure you check. What's the outer? Negative 6x. What's the inner? Positive x. When I add them up, do I get a negative 5x? Yes. And then a positive 1 times a negative 3 is a negative 3. What about the denominator? How do I factor that? Difference of 2 squares. So how do you factor 4x squared minus 1? 2x plus 1, and then 2x minus 1. All right, now we reduce. My first factor is a 5. Will that 5 reduce to anything in the denominator? No. My next factor is x plus 6. Will x plus 6 reduce with any factor in the denominator? My next factor is 2x plus 1. Will 2x plus 1 reduce with a factor in the denominator? Yes. Right here. Put 1s in their place. Your next factor is x minus 3. Will x minus 3 reduce with a factor in the denominator? Yes. 1s in their place. So I've dealt with all with every factor in my numerator. Now let's write the final answer. And leave it in factored form. So how are you going to write the numerator of your answer? 5 times x plus 6. How are you going to write the denominator? Leave it in factored form. 4x times what? 2x minus 1. 4x times 1 times 1 times 2x minus 1 is just 4x times 2x minus 1. And that's all you can do. Now, leave it in factored form. Don't multiply it out. The denominator might be, for some of you, I mean, it's not that bad because you can distribute here, but you could still mess up somewhere. So if you go further and you make a mathematical error, I can't give you full credit. So just be careful. So if you want to go ahead and distribute, you can. That will be 5x plus 30. And the denominator, you're distributing the 4x. So that's going to be 8x squared minus 4x. All right? But leave it in factor form. This is what I would leave it as. All right, so that's multiplication. Multiplication is easy. So remember, in order to have done that, you need to have known how to simplify rational expressions. That was last week. Then we talked about opposites, so you know how to deal with opposites now. And now multiplying, to multiply, you have to simplify. You have to factor first, and then reduce, and then you multiply the numerators and multiply the denominators. All right, now we're about to talk about division. To talk about division, you got to know this. You have to know how to multiply. All right, let's talk about division.